Cellular injury starts the inflammatory process. Cellular injury can occur from toxins, infection, trauma, or systemic injury. Mast cell degranulation consists of the release of histamine, which vasodilates and causes leaky capillaries, kinins, which essentially do the same thing as histamine, prostaglandins that are released to help with the pain, then chemotactic factors, which tell the white blood cells where to go.
Next, the vascular response happens and can create exudate.
Neutrophils then arrive at the site and stick to the vessels and move into the site of injury.
Some of the hallmark signs of inflammation are nausea and heat.
To recap our video, cellular injury starts the inflammatory process. Cellular injury can occur from toxins, infection, trauma, or a systemic injury. In our video, it was trauma, with Hank being scratched by the cat. After cellular injury occurs, mast cell degranulation happens. Mast cell degranulation consists of the release of histamine, which vasodilates and causes leaky capillaries, kinins, which essentially do the same thing as histamine, prostaglandins that are there to help with the pain, and chemotactic factors that tell the white blood cells where to go. After mast cell degranulation occurs, the vascular response takes place. The vascular response is responsible for vasodilation, increasing capillary permeability, and creating exudate. Next, the cellular response takes place. The cellular response consists of margination, diapedesis, neutrophils, monocytes, and lymphocytes. White blood cell neutrophils arrive at the site and stick to the insides of the vessels, and the vessels will open and they'll move into the site of injury. Lastly, there will be healing. Healing has three different intentions. There's primary, secondary, and tertiary. The hallmark signs of inflammation can be split into two categories: local response and systemic response. Your local response will consist of redness, heat, swelling, loss of function, pain, and exudate. Systemic response would consist of leukocytosis, malaise, nausea, fatigue, increased pulse and respiratory rate, fever, elevated CRPs, and ESRs.
To explain the immune response, it's the body's ability to resist disease, and it includes the B and T cells. The B lymphocytes differentiate into plasma cells and produce antibodies, also called immunoglobulins. Then the T lymphocytes attack the foreign substance, otherwise known as antigens. There are different types of T cells, such as the helper T cells. They help produce cytokines and are responsible for communication between immune response and inflammatory response. They help provide with the directing of other T cells, telling them where to go. They also call up macrophages and help them work together. Another type of T cells are the suppressor T cells. They are important because they help calm your immune response so it doesn't start attacking your own cells. The T and B cells multiply and provide memory for the immune system so that the next time you're exposed to a foreign substance, your body should be more efficient and respond faster because your immune system recognizes the foreign substance.